Hello all, good morning. This is Dr. S. Subalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability and Statistics, and now we are on to the topic Design of Experiments, One-Way ANOVA Classification. In the previous video, we have seen the procedures involved in one-way ANOVA classification, which is a completely randomized design. And in this video, we are going to see the problem regarding the completely randomized design. The problem goes like a completely randomized design experiment with 10 plots and 3 treatments gave the following results. We are given with the data for the 10 plots and the 3 treatments. What are the treatments here? A, B and C. And how many plots are there? 10 plots are there. And the yield ratio for all of the tests is given here. The yield for all of the tests is given here. All of the plots are given here. So what we have to analyze with? We have to analyze the result for the treatment effects. Effect of the treatments as conducted for the plots is to be analyzed. To start with the solution as per the procedure learnt earlier, step 1 is null hypothesis. What we will frame? H0. There is no significant difference among the average yields in the treatments. This is what we are going to frame as the null hypothesis. There is no significant difference is the key point here. Second step. What is our second step? Second step is nothing but to frame the alternative hypothesis. What is our alternative hypothesis? Alternative hypothesis is complementary to the null hypothesis. Therefore, there is significant difference among the yields in the 3 treatments. There is significant difference among the average yields in the 3 treatments. This is our alternative hypothesis. Now, moving on to step number 3. Before moving on to step number 3, we are in need of a minor calculation for the capital X's and N1 and C1s. So for that, we are splitting up the given data into this kind of 2 tables. First set is treatments accordingly to the treatments. What are the plots or the yields shown here can be mentioned as table number 1. So for A, it is 5, 7, 3 and 1. A treatments have been handled for these kind of plots. And B treatments for 4, 4 and 7, and C is for 3, 5 and 1 as per the data given in the question we have mentioned here. And for table 2, we have just taken up these as the columns. We have taken up this as column number 1, this as column number 2, this as column number 3. And we have taken up this as column number 1, this as column number 2 and this as column number 3. So this is what we have taken up as columns, and therefore in column number 1 we will be having for treatment A, therefore 4 entries are there, and column number 2 we have 3 entries, and that is for treatment B, and column number 3 we have 3 entries again, that is for treatment number C. So this is what we have mentioned here, and what we have done here, we have sum of the values for x1, x2 and x3 for treatment A, B and C, and also since for the future calculations we are calculating x1 square, x2 square and xt square also. So what will the values mentioned as per the table can be noted down here. Moving on to step number 3. What is our step number 3? As per the procedure, it is calculating n, which is total number of plots, which is equal to 10, and calculating the total number of treatments, which is C is equal to 3. So this is what we are going to do in step number 3. Moving on to step number 4. What is step number 4? T is equal to total number of the given items, which is T is equal to summation of x1 plus summation of x2 plus summation of x3. As we have done in the table, we are just summing up all the entries here, which is T is equal to 40. What is our CF? It is T squared by n, and therefore CF is equal to 160. And later SST, to calculate SST, what we have to do? We have to sum up the squares minus the correction factor, therefore this value is 40 again. And again we are going to see the value of SSC. What is SSC? We are going to take summation of x1 the whole square divided by n1 plus n2 plus n3 minus the correction factor, therefore SSC is equal to 6. And step number 8. Step number 8 is calculating MSC. What is MSC? SSC by C minus 1, which is degrees of freedom is C minus 1. And on calculating it, we have got the MSC value to be 3. And later, step number 9, we are going to calculate SSE. What is SSE? It is SST minus SSC as calculated previously. We are just copying down the values from the previous steps and doing up the particular step here, which is 34. And later, step number 10, MSE is equal to SSE by n minus E, which is MSE is equal to 4.86. So n minus E is the degrees of freedom for the errors. So moving on to the actual thing, which is our ANOVA table. The first column will be sources of variation, degrees of freedom, sum of the squares, mean sum of the squares, variance ratio and table value. So These are our topics here, and in the ANOVA table between columns and between errors as mentioned, since it is a one-way ANOVA, and in the first column degrees of freedom, which is 2 as discussed in the procedure. This is 2 and this is 7, this is 6 and this is 34 from the steps, and MSE is 3 and MSE is 4.86. Here we note that MSE is bigger and therefore this should be on the numerator, MSE is on the numerator and MSE on the denominator. Now on calculating it, the calculated value is 1.62, and from the table we notice that it is this is degrees of freedom for MSE, which is 7, 2. Notice that this is 19.35. So which one is lesser? Obviously we can say that F calculated is less than F tabulated, and therefore we accept the null hypothesis, and therefore what we can conclude, the tree treatments are not significantly different. There is no significant difference among the average yields of the tree treatments. This is what we can conclude using the one-way ANOVA classification. So this is a major important table to note or to find the variations happening among the given questions. So this is how we proceed with the problem on one-way classification. We'll have another problem on the next class also. Thank you.